All right, everyone. If you weren't here, then uh, you missed some more scenarios here. I guess I can move myself away here. So you may have missed some more scenarios. We did 3 scenarios last week or Monday, if you're block 2 group. And today we did a few more scenarios. And then I assigned worksheet 1 from unit 3. Now, scenario 4, if you look at this scenario, and again, you're going to be creating some predictions, hopefully, the same kind of format that we had before in the first 3 scenarios. Remember, we had, let's see, for instance, this would have been scenario 3. I had the ramp set up so that it was coming down this way, that way, going faster toward the 0 in the negative direction. So hopefully you were able to maybe start making, at least with the motion map, hopefully you were able to start making some progress in getting some things correctly predicted. So for each of the next 3 scenarios, going to be 4, 5, and 6, go ahead and you will sketch the diagram here and write down the description for the scenario. Then again, you'll be sketching like a motion map thing, a position time graph thing, a velocity time graph thing, and then we'll see what that's supposed to look like after you've had time to think about it and maybe make some predictions of your own. So that was scenario 3. Again, it was getting faster going toward the 0 position, getting faster going toward the 0 position. That the acceleration then is negative. We saw a negative slope on the VT graph. We saw a slope here that started with none, and then it got steeper negatively. Got steeper negatively here, like that. Okay, so that was scenario 3. Scenario 4 is this. It's going to be, again, traveling in the negative direction. It's going to be slowing down as it goes up the track. It's going to go up the track from the negative side, slowing down as it goes up until it stops at the top. Wait a minute. Am I pointing the right way? This way. Yeah. So slowing down toward the 0 position. So sketch this, write that out, pause, make some predictions, and then I'll show you what's going on. So motion map. Starting with a positive position, traveling toward the 0, and slowing down. Starting with a positive position, traveling toward the 0 position, and slowing down. The XT graph should start with a large negative slope and then change to a 0 slope. Starting with a large negative slope, changing to a 0 slope. So that would look like this. That's a large negative slope, starting with a positive position away from the 0, large negative slope, and then becoming a 0 slope. So steep at the beginning, steep and negative at the beginning, not steep, flat, level, 0 slope at the end. Again, I don't know if that makes sense or not, but that's what we saw happen with the motion detector and the data that was collected. Now, if you're starting with a large negative velocity, large negative, where is that on the VT graph? Below the T, right? And it's going to be changing, getting closer to the 0 velocity. So that's starting below and then going up. Like this. Now, what we have to remember is that the slope of this graph right here, the slope of the VT graph, is what we call acceleration. What kind of slope is that? even though it's below the t, because the velocities are negative. So anytime we have negative velocity, oh, is that even, am I pointing the right way? Anytime we have negative velocities, you're going to have a negative slope here. The line's going to be in the negative part. Whenever we have negative velocities, you're going to have a line on the VT graph below the t-axis, because that's where velocities are negative. And negative velocities mean you're going that way. So that positive slope, though, means we have a positive acceleration, which is why the arrow is pointing to the right in our motion map. So again, I don't know if you predicted that or not, but that's the way it is. Scenario 5. So scenario 5, I flip the ramp back around the other way, and the car goes up. So I give it a push at the bottom. At the 0 position, I push it. I send it up the track, it goes up the track, and then it comes back down the track. So I push it at the bottom, so it starts fast, going up the track, so to the right, that's positive. It goes up, it slows down to a stop, and then it rolls back down, speeding up as it goes down the track. So sketch that, draw that, make some predictions, come back. The motion map. Starting at the 0 position, moving in the positive direction, getting slower as it goes. It finally stops at the top, and then it speeds up, going back down the track, back to the 0 position. So it's going up the track, slowing down, coming down the track, speeding up. That's what this shows. And that gives us a curve that starts with a large positive slope. The slope changes to 0 slope. Again, I'm talking about steepness here, okay? So if you can imagine putting a slopeometer, a pencil on the curve, starting with a positive, as the line goes, the slope gets less and less and less and less steep until finally it has no steepness at all. Then it starts to get steeper, but it gets steeper negatively. That's a negative slope. And so I hope you're seeing it goes from, oh, wait a minute. Am I doing this backward? It goes from oh gosh, what is that? That's positive. So it starts from a positive slope, goes up until it becomes 0, and then it goes to a negative slope. So see, here's what is so confusing about this. I don't care that the line's going up and the line's going down. Like where the line's going, I don't care. It doesn't matter. This just means it's going out and coming back. The fact that the line goes up and then comes down. What is important is the steepness of the curve. It's very steep and positive at the beginning. And then it becomes a negative slope by the end. So on the VT graph, steep and positive means fast and positive. Then 0 slope, and then steep and negative. And that looks like this. Starts with a large positive velocity, gets less and 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 less until finally it has none. There's no velocity. Then the line just keeps on going. Now it gets faster and faster and faster and faster, but it gets faster negatively. That's the coming down the track. So this is going up the track and slowing down until it stops, turns around, and then goes down the track getting faster. But it's just one long continuous line. One long continuous line. So again, that is a negative slope here on the VT graph, which means we have a negative acceleration on the motion map. Again, I know this can be very confusing, but this is the way it is. Now for scenario 6, all I did for scenario 6 is I moved the 0 position from here to in the middle of the track. All I wanted to see was if the same motion happens, but I start the car behind the 0, what does that look like? So again, it's the same scenario. The car slows down going up the track, then speeds up going down. So same thing. I give it a push down here. It goes up the track. As it slows down, stops, and then speeds up coming down the track. So what does that look like? Well, in terms of the motion map, it looks exactly the same as we had before. Only instead of starting at the 0 and going out this way and then turning around coming back, we're starting at a negative position, traveling in a positive direction until we stop, and then traveling in a negative direction, speeding up, but we go past the 0 and end up on the negative side of 0 where we started. That's the only thing that's changed. The only thing that's changed is this, the 0 position here. Oh, I locked it. I wonder if I can make all these connect. Group. So all that changed was it was here like this. It was like that in the last one. Now we've just moved it like this because the 0 position has shifted. That's all that's happened. The motion is exactly the same, which means our XT graph should look exactly the same. The only difference is instead of being up here, now it shifted down because it started with a negative position. Still, though, with a large positive slope, the slope got less and less and less and less steep until it got to 0 steepness, and then it started getting steeper, but steeper negatively, and that's the same thing we see happening here. Question is, does the VT graph look different at all? And the answer is no. What kind of slope do we have at the beginning? Still, fast, positive. What kind of slope do we have at the end? Still, fast, negative. What kind of slope do we have in the middle? 0. 0 velocity in the middle. Remember, the one thing that a VT graph cannot tell us is what? Position. It can tell us displacement. It can tell us velocity. It can tell us direction. It can tell us when. It can tell us the time things happened. But it can't tell us where anything happened. That's what we need the XT graph for. Then what I did next is I compiled all of the motion maps so far. I compiled all of the motion maps that we've had up to this point. Scenario 1, 2, 3, 4, 5, 6, all of the motion maps all together. Question, what is the pattern here? What is the pattern? There is a pattern with the A, the acceleration, and the velocity arrows. There is a pattern. The question is, do you see the pattern? Do you see what the pattern is here? First look at all of the motion maps where the velocity is getting bigger, where it's getting faster. That'd be this one, right? Velocity is getting faster. Arrows are getting longer. If the arrows are getting longer, that means it's getting faster. Arrows are getting longer. This one. Arrows are getting longer. Not here, not here. This one. Now on this part, arrows are getting longer on this part. And of course, same thing down here. Arrows are getting longer on this part. So on this one, the bottom part here, bottom part here. In all 4 of those situations where it's getting faster, the A is a certain way. Do you see what's happening? A is in the what? Well, that's positive, that's negative, that's negative, that's negative. Well, okay, so the A's aren't always facing the same direction, but they are in the same direction as what? The A is in the same direction as the velocity here. Speeding up, A arrow and velocity arrows are in the same direction. Here, speeding up, the A arrow and the velocity arrows are in the same direction. Here, on the downward part, coming back toward the 0, A is in the same direction as the velocity arrows, and it was speeding up. Down here, A is in the same direction as the velocity arrows, and it's speeding up. How about all the ones where it's slowing down? Like here, slowing down. Here, slowing down. Up here, slowing down. Up here, slowing down. What do you notice about the A in each of those 4 cases? A is in the opposite direction of what it's going. Opposite direction. Here. Again, opposite direct. Oh, no, not here. Here. Opposite direction of where it's going. Up top here. Moving in the positive direction, but slowing down. A is the opposite direction. Again, up top here. Moving in the positive direction, but slowing down. A is in the opposite. So that's the pattern. The pattern is that when A and V, when your acceleration and your velocity arrows are in the same direction, you're speeding up. When the A and V are in the opposite direction, you're slowing down. You might want to jot that down. When the acceleration and the velocity arrows are in the same direction, you're speeding up. When they're in opposite directions, you're slowing down. That is the pattern that we're seeing here. So that means I should be able to give you this motion map right here. And you should be able to tell me what direction the A is. What direction would the A be here? Well, is this speeding up or slowing down? Speeding up, because the arrows are what? They're getting longer. Arrows are getting longer. That means we have speeding up, but it's speeding up in the negative direction, which means A has to be in the, if it's speeding up, same direction. So our A in this case has to be in the same direction as the velocity, because it's speeding up. Now, what good does this do? Well, here's what good it does. The only reason we knew what direction to put the A arrow here was because we looked at the VT graph. Remember, the slope here tells us what the A is. Negative slope on the VT means negative arrow here. Let's see. Negative slope on the VT graph means, again, negative arrow here. Let's see what else we have. Positive slope on the VT graph means positive arrow here. Negative slope on the VT graph meant negative arrow here. Negative slope on the VT graph meant negative arrow here. And finally, positive slope on the VT graph meant positive arrow here. So, because the VT graph is the same as the arrow for our A on our motion map, here's what this is going to do for us. What I'm hoping is, just like down here on this last motion map here, if you can sketch a motion map, which I think is probably the easiest part. The easiest part of all of this is sketching a motion map, because it's just kind of giving us a picture of what the motion looked like. Like typically you can figure out if it's speeding up or slowing down and which direction it's going. And if you can do that, then you should be able to figure out with these 2 statements here, you should be able to figure out which direction the A needs to be on your motion map. And since this is the case, we know then that the slope on our VT graph has to be a negative slope. Why? Because we have a negative acceleration. Our motion map says the acceleration is negative, so that means we need to have a negative slope on the VT graph. Or no, that'd be negative slope. That is what is going to help us, I hope, anyway. So with that said, I posted an assignment, and it has a bunch of these kind of curves. It has a bunch of like position time graph curves at the beginning of it, and it tells you what to do. You're supposed to describe the slope of the curve and what the slope's doing. So whether it's positive slope, negative slope, and whether the slope is increasing, whether the slope is decreasing, or whether it's constant. So that's what you're supposed to describe. And then there's some other questions about, there's actually a data set of a time and velocity data set that you will plot a velocity time graph, draw a best fit, find a slope, write an equation. The same kind of stuff we were doing, only now it's on a velocity time graph, not a position time graph. So that's due for the next class period. So I think that's it. Hopefully this maybe helped, maybe not, I don't know. But I know this stuff can be incredibly confusing. I'm hoping in the next couple weeks things will clear up and everybody will be on the same page. So take care of yourselves. We'll see you later.